Welcome to Chapter 6. This chapter is all about chemistry of food and plants, so here we go. So we're going to look at anything from minerals to vitamins to elements, carbs, water, protein. We're going to look at all of it and how it's interacted with the food that we grow. Elements, okay? So one thing that I want you to know is that everything is made up from an element. So anything from lipids to carbs to water, they're all very, very important compounds that are made up of elements. So for example, carbs are monosaccharides, they're disaccharides, and then there are polysaccharides. And you probably, that's probably very familiar to you in terms of nutrition. And we'll talk about that in a little bit. 3 different types of lipids, which we'll talk about. And then one very important aspect about proteins are that those compounds are amino acids. Okay, so make sure that that kind of wraps around your head, and you'll read a little bit more in depth about that this week. And we're going to do some fun activities that have a lot to do with making those elements and those compounds as well. Also, water, okay, H2O, there's your compound, is very, very important to the essential for all life on Earth. So elements, what are they? Everything, like we just talked about, is composed of elements. There's more than 100 elements that exist. 91 of them, though, are actually naturally occurring. The atom is the smallest component of those elements. So think back to your chemistry days, or if you're in chemistry, you're going through this right now. And every element has an atomic number. How do we use that atomic number, and why is that important in agronomy? We'll talk about that as well. And then atoms then combine, so they're forced, in some cases, they're forced to combine to form compounds. So let's look at those compounds of carbs, of proteins, of lipids, of water. Okay, so if you look at it, you all know what water is composed of: hydrogen and oxygen, H2O. Okay, let's look at carbs. That is composed of carbon, oxygen, and hydrogen. Okay, now look at lipids, composed of carbon, oxygen, and hydrogen. Well, wait a minute, Allison. Why are you telling me that carbs and lipids are composed of carbon, oxygen, and hydrogen? What is the difference there? What do you think? That the difference is how it's being composed and how much of each of those elements are in that composed area. Okay, so we'll talk about that a little bit more. We're going to have a fun little chemistry lesson this week. Protein, that's nitrogen, hydrogen, oxygen, and carbon. Okay, so make sure that you look at all 4 of those in this week, and make sure you know all 4 of those when it's time to go to class. Okay, so now let's look at the ratio of carbs. Okay, so we just talked about what it's composed of. All right, so that ratio is a 1 to 2 to 1. All right, so how that is composed is very important in terms of how that plant is going to capture its sunlight and then photosynthesize. So that is actually, with carbs, is going to be about half of that caloric intake for people. So then we have to look at how it's classified. Is it a monosaccharide, a disaccharide, a polysaccharide? How are those compounds going to help that plant make a carb? Building block for more complex carbs, really. So it's going to include glucose, fructose, and galactose. Okay. Then remember that high fructose corn syrup. There's a blend then forms of fructose and glucose. Okay, high fructose corn syrup. Okay, is then blended to fructose and glucose. Excuse me. All right. So if you look at this, we talked about sweeteners a couple chapters ago. This is a table that's also in your book, but I just want you to kind of look this over. So we just talked about glucose and fructose. So look at those. Glucose, 50 to 80, all right, 50 to 80. Fructose, 110 to 170. Now go down to high fructose corn syrup. So 42% fructose, 80 to 90, all right? So that's the relative sweetness of different sugars in how we utilize them in food. So what does that mean? And again, this is on a rate of rated on 100 on the scale. Okay, what does that mean? Okay, I want you to now look at honey. Okay, 90 to 105. Now, honey is natural, right? We can't make honey in a manufacturing facility. We can't do that. We don't make honey, but we can make all of these other things, right? In different forms of breeding plants. So that's kind of interesting in terms of sweetness and in price. So is it going to be cheaper to utilize high fructose corn syrup other than honey? Okay, so that's kind of what we'll talk a little bit about more this week in class. Saccharized before it's then metabolized into those cells. And then it then includes a sucrose, a maltose, and a lactose. And then the sucrose is the most important because it has that glucose and that fructose. Okay, so when you're putting all of those together, that's very vital to the way it tastes, the way it's going to be composed, the way it's considered to be classified. Those are all very important aspects of a disaccharide. So this is just the molecular structure of the glucose and the fructose, which is the sucrose, the maltose, and then the lactose. Okay, so you can see there's a lot of different hydrogen, carbon, and oxygen, and they're being they're being pushed together in different ways, right? It's not all the same, so it's making different classifications of them. Polysaccharides going to be many, okay, poly equals many units and then joined together. So it's going to be able to store a lot more energy, and that structural compound is going to be better. Not necessarily better, but it's going to be able to have more structural compound. That is then going to include the cellulose, and we talked about the cellulose a little bit when we looked at cellulotic fuel. And then those energy storage compounds come into place, and which is also a starch, and then it will produce that starch. Digested by humans, but it can be digested by ruminants, okay? So a great example of that would be like corn silage. So we can chop that entire corn plant, make it into a silage, cut it up into a silage, and feed it to ruminant animals. But you and I, we cannot eat and digest that whole entire corn plant. Okay, so that's something to be very aware of. So that's just the cellulose is just that structural support for the plant. So it's the whole, for example, corn plant, that cellulose is that entire structure of that corn plant. It is pretty big when you look at woody or vegetation plants, but it's the least in grains. And it can also be converted into ethanol by fermentation, like we've talked about as well. So this is the molecular structure of cellulose. You can see there's a big 3-layer secondary wall. You have many different molecules of glucose and then cellulotic or cellulose molecules as well, and then there's the fiber, and kind of intertwining in all of those. That is how we look at that molecular structure of cellulose.